Hello, Math B. We are going to do lesson 7.1D, and we're looking at linear, means a line, and nonlinear patterns, things that are not a line. Complete Foods, a local grocery store, has hired two different companies to design a display for the food items that are on sale each week. They currently have a display that has 6 boxes wide. They would like the center part of the display to be taller than the outside pieces of the display to showcase their mega deal of the week. The following are the designs for two different companies submitted for Complete Foods. Use the current display as their starting point. Okay, so I look at the first one and I see that there's 6 boxes. And then I look at the next one, 1, 2, 3, 4, 5, 6, 7, 8 boxes. And then I look at the next one and there is 10 boxes. So if it is linear, I know that every time it is adding between the stages, it's adding the same amount. So here, when I'm looking at this, I go, all right, I see that this is adding 2 and adding 2 and adding 2. And then I have to always remember what stage 0 was. So we did this back a couple modules. So stage 0 would be 2 less than 6, which is 4, because that's our y-intercept if it's linear. So we always have to pay attention. What would stage 0 be? And it might not make sense geometrically what it is, but you'd still be able to figure out what kind of boxes there were. Okay, so here I can design the next one. So I'm going to go ahead and get my rectangles out and draw it up. Whoa, that's a very large rectangle. Okay, I'm not loving this rectangle. We're just going to do it by hand. Okay, so I know there's 6. And then it's going, I had 2 up before, but now it's going to be 3 up. Then I know I have a total of 12 because I added these 2 to that middle. Okay. Can the relationship between the stage and the number of boxes be modeled by a linear function? And I say, yeah, because I see that every time it is increasing by 2. So there is a constant rate of increase. So I can figure that out. So the answer is yes. Okay, so here we're recording. And remember, I drew stage 0. I didn't draw stage 0. I talked about stage 0, but on our table, we're just doing what they had. So in stage 1, there were 6. In stage 2, there were 8, and so on. Okay, then I have to put something I didn't draw. I'm going to go ahead and put stage 0 because I find stage 0 to be really useful for everything else I'm going to do. But you can put stage 5 or whatever you want. I know at stage 0 there would have been 4. So I had to create one for the bottom. Okay, is it a function based on the table of values? Yes, because every stage is only giving me one output, one answer. So here, yes, every stage corresponds to a unique number of blocks. Okay, remember your x has to go to just one y, not 2 y's if it's a function. And here, is it linear? Yes, because every time it's increasing by 2. Yes, there is a constant rate of increase. Okay, we are adding 2 boxes per stage. Okay, so when I graph it, I know it's actually going to look like a line because it's a linear. Okay, so I'm busting out my line. Again, at stage 0 rate, there's a constant rate of increase. There we go. I don't know why it doesn't like that. Okay, so at 0, at 1, there's 6. There's not really a half of a stage, so we're not connecting them. It is discontinuous. It's still linear and just discontinuous. 2 is 8. Oh, I have to go back. It's not 0 at 0. It's 4 at 0. It is 4 at 0. Okay. And then boom, boom, boom. Okay. Is the graph of a function, is the relationship a function based on the graph? Yes. There, you can't hit 2 exponents with 1 y. It passes the vertical line test. Remember, if it's not a function, I would be able to take a vertical line somewhere through the graph and be able to hit at least 2 points. Is relationship linear? Yes. The points lie along a line. Okay, so my equation, y equals mx plus b. I see that my y, which is the number of boxes, is equal to an increase of 2 boxes each stage, and my y-intercept is 4, because at stage 0 there would be 4. Yes, it is in the format of y equals mx plus b. All right, moving on. Justify that the pattern represents a linear growth by using a model. Okay, the growth is only in one direction. It's just increasing up the middle. The growth is just in one direction. It increases boxes up the middle column. If we had growth going in different directions, we might have not linear. Okay, moving on. Here, let's look at what they're doing. They start out with the same 6. And I see that they're adding 3 to get to here. So now they are at 9. 1, 2, actually, what did they do? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, no, they added 4. Okay, so they put an additional one here and here. Okay. And then they added 4. Let's see. 1, 2, 3. This was 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They added 6 more. They added an additional here. And one kind of column like that. So they're putting a row and they're putting a row and a column into there. Okay, so we need to increase the bottom 1, 2, 3, 4, 5, 6, 7, 8. So the next one's going to have 9 across the bottom. Start my drawing. I have to draw small to fit this one in. Nine across the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then they're going to have still 2 on each side, but they're going to have a stack of 3 up. So we'll be adding 1, 2, 3, 4. 1, 2, 3, 4. This one got added. Nope. We're adding all of these. Okay. So again, we look at here. 1, 2, 3, 4, 5, 6. They added 6. Here we are adding 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I can tell it's not linear because the first time I add 4, the next time I'm adding 6, the next time I'm adding 9. I keep increasing what I'm adding by another one. Like this added is a difference of 2. This is a difference of 3. So I'm keep adding more. Okay. Can the relationship between the stage number and the number of boxes in this pattern be modeled by a linear function? Okay, so we're looking, and my answer right now is no, because it doesn't have the same increase every time, but we'll look at what it looks like. Okay, so here we're going to write down our stages. So stage 1 had 6 blocks, and stage 2 had 10 blocks, and stage 3 had 16 blocks, and stage 4, I added 9, but I never actually wrote how many blocks I had. Stage 4, we had 24 blocks. Okay, so we got to come up with these other ones, and we have to kind of go, looking at like first differences, second differences. So going back, this is going up by 1, up by 1, up by 1. This is going up by 4, up by 6, up by 8. So the first difference is not the same. So then I go explore the second difference. 2, 2. So I can work backwards. So if I went up 2 more, that means I would be increasing 10 more, which put my next stage at 34. Same thing here. If I increase 2 more, that would put me 12 more, which would put my next stage up at 46. I like to know where my 0 is. So going backwards, if I decreased 2 more, that means I added an additional 2 more, which means I'm back at 4. So these ones I kind of have to explore my pattern to figure out what they would be. Okay, definitely not linear. I'm going to go ahead and graph. At 0, I'm at 4. At 1, I'm at 6. At 2, I'm at 10. This would be 12, so 10's in between. At 3, I'm at 16. At 4, I'm at 24. At 5, I'm at 34. This is 36, so 34 is kind of in the middle. At 6, I'm at 46. Okay, so I see that it is making kind of a U shape. It's half of a U, which means it's quadratic. The second difference, there's an x squared in the term because the second difference is the same, but not the first difference. So here, is it a function? Yeah, based on the table, every input's only giving you one answer. So yes, for every stage, there is a unique, there's not two different answers, unique number of boxes. Okay, over here on the graph, it is a function because it passes the vertical line test. I can't put a vertical line and hit 2 points. Yes, it passes the vertical line test. Okay, is the relationship linear? No, the first difference is not the same. Okay, no, it lies along curve. Justify that the pattern does not represent linear growth by the model. So in the model, it's going in two directions. The bottom is getting wider and the top is getting, the middle column is getting taller. Okay, remember if you're not keeping up, you can always hit pause and catch up. Okay, we are moving on to the next page. Owen earns quarters each day he makes his bed in the morning. On the first day, Owen's mom gives him 2 quarters. On the second day, his mom gives him 4 quarters. On the third day, he receives 6 quarters, 8 quarters on the fourth day. Owen makes his bed every day, and this pattern continues. He's going to be rich. The model shows how many quarters Owen earns each day. Consider the relationship between the number of quarters received on a given day and the day number. What is the independent value and the dependent value? So his money depends on which day he is making his beds. So dependent is the money, the quarters, and independent is the number, the day number. Is it linear? Okay, so we want to look if there's a constant increase or not. So here we are increasing by 2, and then here we're increasing by 2, and here we're increasing by 2. So I see there's a first difference in the constant. So yes, it is linear. Define your variables and write an equation to model the relationship between the number of quarters received and the day number. Okay, so I know that I have to go find the day 0, even though it doesn't really exist. He's not going to get money on day 0, but actually this would show that. He would get 0 money on day 0. So I know that the y-intercept is 0, which makes it pretty easy. So y is going to be the number of quarters on a day. And x is going to be the day number. And we see that my equation, the amount of quarters he gets on a particular day, depends on 2 times that day number. So 2x. All right, next one. Consider the relationship between the total number of quarters he has earned and the day number. Now that's different. So on quarter, number of quarters added that day. So on day 1, he gets 2 quarters, so he has a total of 2 quarters. On day 2, he gets 4 quarters, so now he has a total of 6 quarters. On day 3, he gets 6 more quarters, so he has a total of 12. On day 4, he gets 8 more quarters, a total of 20. On day 5, he gets 10 more quarters, so we have a total of 30. So is this linear? No. We can look at the first difference. Here, this is going up by 4, up by 6, up by 8, up by 10. So first difference, not. We can look at the second difference to see if it's quadratic, if it's an x squared function. Up by 2, up by 2, up by 2. So I see this quadratic, not linear. So is it linear? No, the first difference is not consistent. Consistent. Constant. That works too. All right, new one. Carbon 14 has a half-life of 5,730 years. So a half-life means when you are trying to decay something, like I throw styrofoam into a garbage, I want to know when will the styrofoam be gone. Okay, so carbon 14 will still have half of whatever it had when you started 5,730 years from now. So this is a chemical that does not go away very quickly. Okay, the table below shows the amount of carbon 14 that will remain after a number given of years. Consider a relationship between the number of years and the amount of carbon 14 remaining. So what is independent and what is dependent? So your time, you can't control time. That's your independent. So independent is the years. Okay, and dependent is how much carbon 14 is left. Okay, so I need to look at my first difference to see if it is consistent or not. So this is going up by 5,730. This is going down by 4. This is going up by another 5,730. And this is going down by 2. And then we're going up by another 5,730. And this is going down by 1. Again, up by 5,730. This is going down by a half. So no, first difference is not the same. No, the first difference is not constant. Okay, even the second difference is not constant. This is a different type of equation, but you don't need to go there. All right, hit save, turn it in, and you are on to your homework.